Hello, today we are starting Unit L. We are starting with Lesson 8.4. I split 8.4 up into 2 days. Today we're just going to focus on simplifying rational expressions. We do need to remember how to factor in this whole unit. Okay, so let's go ahead and get started. A rational expression is in simplified form if its numerator and denominator have no common factors other than a plus or minus 1. To simplify a rational expression, we're going to apply the following property. Let a, b, and c be expressions with b not equal to 0 and c not equal to 0. Then the following properties apply. So basically what we're doing is we're dividing out a common factor. In the property, if you see in this problem, our common factor is c. We cross c off. We're left with a over b. Down below, when we split up 15 into factors and 65 into factors, we see that there's a common factor of 5, so we divide those out. If I look at this, which is mostly what we're going to be doing, if we factor polynomials, the top and the bottom, they have a common factor of x plus 3, so I'm left with 4 over x minus 5. Okay, so basically our two rules are we want to make sure that the numerator is factored and the denominator is factored, and then we want to divide anything out that is common. So let's just go ahead and get started. So number 1 and 2, these expressions are already factored. I don't need to do any factoring, I just need to look for anything that's common that I can divide out. So x plus 1 is common. In the numerator, I'm left with 2, and in the denominator, I'm left with x plus 3. Okay, in this problem, I don't have anything that's common. Now remember, you can't divide out a 2 because of this expression. Okay, we cannot do that. So this already is in simplified form. So you just write simplified form. Okay, let's go ahead, move on to the next two problems. I started with simple type factoring, and then we'll get a little bit more complicated. But the factoring is what we have been doing all year long. So number 3, look at the numerator. I only have 2 terms. They're not a difference of squares, so I'm just going to take out a GCF. I can take a 20 out of the numerator. When I do that, I'm left with 2x plus 1. In the denominator, I can divide out a 10 or factor out a 10. I'm left with x plus 3. Now, I can't do anything with the parentheses, those stay. I can take a 10 out of the 10 and the 20. So in the numerator, I'm left with 2 times 2x plus 1, and in the denominator, I'm left with x plus 3. Now, we do not need to multiply this back out. Just leave it, and this is your answer. Okay, number 4, numerator, I cannot factor that out, but the denominator, here I have 2 terms, no GCF, so this is difference of squares. If I square root x squared and I square root 16, I get 4. So I have x and 4 in both parentheses, and I have 1's a plus, 1's a minus. The x plus 4 factors out. Now, what's left on top? Don't tell me 0, it's a 1. So when I divide x plus 4 by x plus 4, I'm left with a 1. So 1 over x minus 4. Okay, we're just going to go ahead and keep factoring, and then at the end, I'll have some tries for you to try. Okay, number 5. This is easy AC factoring. Easy AC factoring because I have a trinomial and it leads with 1. So I take my negative 15 and I say what multiplies to give me negative 15 and adds to give me negative 2. That's negative 5 and 3. That's what goes in my parentheses. So x minus 5, x plus 3. The denominator is difference of squares because it's a subtraction sign, and those are perfect squares. So I have x minus 3 and x plus 3. The x plus 3's cancel, and I'm left with x minus 5 over x minus 3. Okay, next one. 2 trinomials, simple AC factoring because they both lead with 1. So in the top, what multiplies to give me a negative 3 but adds to give me a negative 2, that would be negative 3 and positive 1. On the bottom, what multiplies to give me a negative 6 but adds to give me a negative 1, that would be negative 3 and positive 2. Then x minus 3 is divide out, and I'm left with an x plus 1 over x plus 2. Anytime you want to pause the video and try some of these on your own, go ahead. Okay, number 7. These are not difference of squares, so I'm just going to try taking out a GCF. In the top, I could take out a 2x, so I'm left with x plus 5. Now, the bottom, this is our more complicated AC factoring. I'm going to do this one full out, reminding you how to do it, and then when we when you try a U-try problem, you can try that one on your own. Okay, so when I have a trinomial and it doesn't lead with 1, I take my 3 times 5. Multiply those, you get 15. What multiplies to give me 15 and adds to give me 16? That would be 15 and 1. Now we're going to rewrite our middle term. I leave the 3x squared alone and I leave the 5 alone. I write my middle terms as 15x and 1x. Then I'm going to take a GCF out of these two. So I would take a 3x out, and then I'm going to take a GCF out of these two. If there's not a GCF, you can take out a 1. Remember, these two parentheses that are left must be the same. If not, you factored incorrectly. So take a look at the step above. Now I'm going to factor out an x plus 5, and then I'm left with my remainders, 3x plus 1. So we have x plus 5 and 3x plus 1. What divides out? The x plus 5. So my answer is 2x over 3x plus 1. Okay, let's go ahead and try the next problem. Back to simple AC factoring because the numerator leads with 1. What multiplies to give me 28 and adds to give me 11? That would be x plus 7 and x plus 4. The denominator, no difference of squares. There's no subtraction sign. These are not perfect squares. So we take out a GCF, which would be a 2x. I'm left with x plus 4. The x plus 4s divide out, so I'm left with x plus 7 over 2x. Okay, now I would like you to pause the video. I would like you to try these 3 U-try problems on your own. If you come in tomorrow with these incomplete, you are not going to get credit for the video. So you're going to factor the numerator and denominator separately. Make sure you try number 2 and number 3. I purposely gave you AC factoring that does not start with a 1, so you're going to refer back to my example number 7. And then if you have any other questions, comments, or concerns, please write them at the bottom of the paper, and I'll see you tomorrow in class.